So good morning once again. We're looking at joints and some other in today's class. In SQL, there are about 6 kind of joints. Hold on a second. 1, 2, 3, 4, 5, 6. Yeah, 6. We have what we call the cross join, the self join, inner join, right join, left join, and full join. Now, for those of you who are familiar with mathematics, there's a particular concept in mathematics topic that would help you understand joints better, right? And that is sets. So if you did sets in your secondary school or your university, you would have no issues understanding joints easily. But if you're not doing mathematics in university, it's still fine. We explain the concept. Now let's just start with inner join. Before we do that, let's just run this so that we get an idea of our table. So this is our table here. You can see this is our table here. And we have number of records there. Right? Now, how does inner join works? Let me set an example so you get it. Inner join is the intersection of 2 different sets or 2 different tables. So take, for instance, let me give an example. If we have table 1 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have table 2 has 2, 4, 6, 8, 10. So these are 2 tables, right? Now, the intersection of these 2 tables, or in this case, inner joins, is the records that we can find on table 1, or we can also find in table 2. That's how intersection works. So intersection is when you have 2 different sets, right, and they have their respective elements, what values can you find? What values are common to both sets? That's what intersection means. In this case, if you say what values are common to table 1 and table 2, you agree with me that will be 2, 4, 6, 8, and 10, because we can find them in both tables. Please, do we get this now? Do we understand inner joins, please? Let me know if this makes sense or not. IJ, Ibrahim, Vivian, Aliyah. Hello, can you guys hear me? Hello?
We can hear you, sir. I can hear you.
Do you understand the explanation of inner joins?
Hmm?
So, IJ, you're talking, but we can't hear you. Or let me say, I can't hear you. I know you're talking, but I can't hear you. I don't know if it's probably due to mic issues or what have you. Elijah, can you hear me?
Yes, I can hear you. Can you hear me?
Okay, it's better, though still low, but it's better. No, it's low. Do you understand the definition of intersection?
Sorry, I didn't
Okay.
get
I
it. I
don't,
don't.
I don't really understand.
Ibrahim, what did you say?
I said I don't really understand. I don't know if you can recap.
Okay, please, I'll take it again. Let's pay attention, please. Let's pay close attention. Now, look at line 10 and line 11. We have two tables and they have different elements. Table 1 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 has 2, 4, 6, 8, 10. Now, the intersection of these two tables will give us 2, 4, 6, 8, and 10. How do we have at this output? The intersection is the values that are common to both tables. We get the values that are common to both tables. So what values can we find in table 1 that we can also find in table 2? That is what we call intersection.
Okay.
Common to both sets or both tables. Let me use tables now. So, and that is how inner joins work. Inner joins would take two tables together, right? Then look at what matching columns can we find. So what matching records can we find? So look at this table. Let me just give an example of this table. This query. Select S dot full name, T dot track name, T dot price from students S, inner join tracks T on S track ID is equal to T dot track ID. I'll explain this query to us. But what I want us to focus on is this place here. So,
Yeah. Inagadama.
hello, Ibrahim. You might want to mute your mic. Now, select query. You will see that on line 7, we have students, then S. This is another way of writing alias. You know, we talked about alias, students as S. Remember? Now, another way of writing it is saying from students S. So, wherever we are using students, wherever you see S, S is denoting what? Students, the student table. So what I'm using here, you are saying select student.full name, comma, T.track name. And what is T? T is representing what? Tracks. It's an alias for tracks. It could be any other letter. And why are we doing this? We are using two aliases like this because we are dealing with two tables. Suppose it's just one table we are dealing with, we probably know it's an alias for the table name. But because we're dealing with two tables, right, we are having to use alias so that we can distinguish one table from the other. So what this query is saying is select the student.full name. Don't forget S representing the student's table, track.track name, track.price from students. You can see the student table, which is noted by what? S. Right? Inner join tracks. So we are joining two tables now, the students table and the tracks table. Tracks is represented by what? T, as you can see here. This on is the condition that establishes the relationship between the two tables. On S.track ID, that's student.track ID, is equals to T.track ID. T is also the tracks table. Don't forget, in this student table, we have a column, which is a foreign key called track ID, as you can see here. Can we see this track ID column? Now you see that there are values here, which is the foreign key, and this track ID column is referencing the tracks table, right? It's referencing the tracks table. Now, if you go and look at the tracks table, let me run that query for us. Select all from tracks. You see that we have 3 records and 3. Okay, no, we have 3 records and 5 columns. As you can see, there's price, there's duration. So when we say tracks T, that's T representing tracks. So you can now see T.track name. We are getting this column, track name, right? And we're getting T.price. We are getting this column, price column. So we're getting 2 columns from the tracks table. the track name, and the price column. But because we are joining two tables together, don't forget that this column, they don't exist in the student table, but the tracks table. So what are we doing? We are joining the students table and the tracks table. And the way we are joining them is using the inner join. And we are joining them through this relationship. The track ID on the student table, where it matches the track ID on the tracks table. So if it found any matching record, take for instance, in the track ID column on the student table, we have a record that says 7. Don't forget, you can see there are 3, 5, 7. These are the records for the primary key here, right? 3, 5, and 7. 3, 5, and 7. Now, are they matching records in the students table? Don't forget what is common to both tables. So we can see 3, 5, 7 is common in this tracks table. 3, 5, 7 is common in this tracks table from the primary key, which is track ID. Now let's on the student table and see if we have matching record or common record. I will see this now on the tracks table, in the student table, I mean. On the track ID column, we can find 3, we can find 5, and we can find 7. Right? So what this will do is, since they are matching records, that means what is common here and is also common here. We can find that is intersection. Right? If we run this query, it will give us, it will mean is it will appear as if we are dealing with two tables together, which is actually what is working, what we are doing. So you can see student of full name, the full name table from the full name column from the student table, the track name column from the tracks table, the price column from the tracks table, and we've been able to get these 3 columns, right, from these 2 tables because they were matching records. Let me know if you understand this, please. Are we together, please? Let me know if you understand this. If you don't get it, let me know, please.
I don't understand.
Okay, Aliyah, right? Okay.
So I don't understand.
We have about 7 minutes. Let me just see that response again. Now, look at table 1 and table 2. Or let me don't do table 1 and table 2. Let me see this. Okay, let me see if I can run this. Let me see if I can do this for you guys. Let me see. Oh, I think we have this issue again. Um, oh, sorry. Precondition. Now look at this query, guys. I want to see this query. Select all from students inner join tracks on students tracks ID equals tracks plus tracks ID. Now observe the columns we are going to have. Can we see that we have columns from the student table and columns from the tracks table, which start from here? Can we see it, guys? Look at this, guys. Do we see the highlighted columns? Hello, guys. Can we see the highlighted columns?
Yes, sir.
These 2 columns, are they common? Are they matching? Hello, are they matching?
Yes, sir.
So what you can see here is this. This first track ID is from what table? This first track ID is from what table?
Okay.
Hmm?
Student.
Student table. Thank you. This track ID is from what table?
Tracks.
Tracks table. So you can see that two tables have been combined together. And how are they combined together? They are combined together via this condition, this relationship. And that's what we are doing here. So inner join is telling us if you can find any matching record, then give us all the rows that match that record. So select all from students, inner join tracks. If you go and check, inner join tracks, you are now joining two tables together. Don't forget, like I explained here, I said table 1 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Table 2 has 2, 4, 6, 8, 10. Look at these two tables example I'm giving you. Do you have matching records or matching? Yeah, do you have matching records from these two tables? Yes or no?
Yes, sir.
Yes.
What are the matching records?
2, 4,
2,
6,
4,
8,
6,
10.
8, 10.
2 for 6. Good. So the match records are 2 for 6, 8, 10. So what that means is if you give us all the records for this matching record, let's look at this again. Can we see matching record 7, 7, 3, 3? So all the records for this matching record, that means everything. When I say all the records, you give us the email, the phone number, the city, the track name, the description, the price. Do you get that now? So if there are no matching records, it will not give it to us. But if as long as it can find a record that matches that ID in the other table, it will just go. It's like saying family. One so somebody from one family, that's the man, somebody from the other family, that's the woman. So when both of them meet and they match, every other person from their respective families can come together. Do we get the analogy? So the student table and the tracks table can now come together because they are matching records from each tables. And the matching record is established from these two columns, the student.track ID and the track.track ID. Does this make sense now? Vivian, Aliyah, IJ, Ibrahim. Do we get this, please? Let me know if you get it or not. Hello, IJ, are you saying something?
Yes, sir. I said yes, I got it.
All right. Thank you very much. What about you, Ijoma? Sorry, not Ijoma again. Ali and Ibrahim and Vivian.
Yes, sir, I got it.
All right. Thank you very much. Aliyah, what about you? Ibrahim, what about you?
I got it, sir.
Now, what we did initially then was we were using alias. So now I'm saying students as S, tracks as D. It could be another letter. I can just come here and say S dot track ID, D dot track ID. We are still getting the same thing, as you can see. So this is another way to do alias. Instead of to say students as S, track as D. You could just write the alias beside it, and it will still be fine. So just know that this another way of writing was alias, right? And that's what we did here in our query. S dot full name, T dot track name, T dot price. From students S is representing students, and T is representing what tracks. So when we come back in the next session, we'll look at the other examples under joins. Thank you very much. Well, 1 minute is quite long.